All right, so there's a variation of nearest neighbor, which is called k nearest neighbor. And the idea is, instead of looking into just one neighbor, we actually look at multiple neighbors, and that value is k. Okay, because there might be some noise in your training data, and if the nearest sample you have that becomes noisy, then your classifier will fail a lot. Therefore, what we do is we look into like multiple neighbors. For example, if it's one nearest neighbor, that's fine. The case we discussed earlier, we just look at the nearest one. We can have two nearest neighbor or three nearest neighbor. Of course, we don't want to do two nearest neighbor, because then if there's a tie, we don't know what's the decision. That's why we always choose like odd numbers. And in case of three nearest, you will actually look into the top three nearest neighbors of the sample. Okay, and then whatever is like the dominant class category, you will just choose that. So you can have 5 nearest neighbor. So the simple algorithm is, you have your samples, you extract features for the testing sample. And for each training sample, you compute the distance from the testing sample. And this is, I will select the most computationally expensive step, which is sort the distances. And you just pick like the classes based on top k samples. K could be like any number, 1, 3, 5, 7, or 9. It's up to you. So the good thing about k nearest neighbor, you don't need any training, and it's very simple and easy to implement. You will see like in your programming assignment, and it can be used for classification, regression, or search a lot of different problems. Now the issue is, so performance is one issue. It won't perform really well in most of the cases. The other issues are, if you have a lot of training samples, then it will be very slow, because you have to compute distances with all those samples, right? And if your features are high dimensional, then again, computing that distance will take time.